Now that we have removed punctuation and tokenized our dataset, we're going to do a bit more cleaning and remove stop words and learn about stemming and lemmatizing. Hi, this is Shanko and welcome back to NLP with Python. So in our previous few lessons, we read data from this file, which contains a list of messages which are categorized as ham or spam, and then we read in that data using pandas library, and we categorized them into two columns with labels as one column and the text or the actual message as another column. And then we explored the data. We saw the number of rows and number of columns in our data set. We checked out the number of hams and number of spams in our data set, and we checked for the null values in our data set. And we have already done a bit of pre-processing. We have removed punctuation. We wrote a method to remove punctuations, and we passed in our data into that method to remove punctuation from our data. And we created this column called text underscore no punct, which contains the text messages without punctuations. And then we tokenized our data. We created a method, we wrote a method to tokenize text into words, list of words, and then we ran that method on our data set, and we created this column text underscore tokenized, which contains a list of tokenized words. Right now we're going to go ahead and convert this into lowercase. So we're going to go ahead and convert all our text or all our characters into lowercase in this text underscore tokenized column. So what we're going to do is we're going to just grab this, go ahead and grab this. So all we're doing here is we are just trying to create this, recreate this column text underscore tokenized, and we are passing in the text underscore no punct column, and we are applying a lambda function, and inside the lambda function we are calling the tokenize method, and we're just gonna do x dot lower, and go ahead and run this, and let's print the first 5 rows in our data set. So I'm gonna say data set dot head, run this. So now we have all our characters in lowercase, and this is important because Python cannot distinguish, or Python cannot separate or cannot comprehend uppercase from lowercase, and GO in lowercase is different from GO in uppercase. So this Go is different from this Go to Python. So we need to convert this to lowercase to make Python understand that we are dealing with the same thing. So we're gonna go ahead and remove stop words, and let's try to understand what stop words are. So we have already spoken about stop words in a previous lessons, and we're gonna revisit stop words. So stop words are basically words that do not contribute much to the meaning of a sentence, and if we are doing stuff like sentiment analysis, they do not provide much input to the sentiment of the sentence, or they are sentiment neutral and they can be removed. So NLTK provides a package of stop words, and we're going to create a method to remove stop words. So what I'm going to do is I'm going to say from NLTK dot corpus import stop words, and run this, and let's take a look at some of the stop words. So I'm going to say stop words dot words, and we're going to select the English language because NLTK provides stop words in various languages. So we're going to select the English language, and I'm going to print the first 10 stop words. So I'm going to say 0 till 10 and run this, and we can see we have a list of stop words. So these are the words that do not contribute much to the meaning of a sentence, and we can remove them. Now why do we need to remove stop words, and why should we remove stop words? So stop words are removed to reduce the number of words Python has to look at or consider, and this is important because Python needs to store this data into memory, and if you are storing more data into the memory that do not provide much input, or that do not provide that are not really important for us, we are just consuming memory space and not utilizing it efficiently. So we're gonna go ahead and remove the stopwords. So I'm gonna remove this, and I'm gonna create a method that can take in a text and remove stopwords. So I'm gonna say def remove stopwords, and this is going to take in a list of text. So we're going to pass in this list, or this tokenized list of words, and we're going to get the stopwords removed. So I'm going to say text underscore list, and we're going to go over, and this is going to remove the stopwords. So we'll store it in text underscore no stop, and we iterate over the list of the words in our list. So I'm going to say word for word in text list. So that's going to go over each word in our text list, and I'm going to say if word not in stop words dot words, and select English. So if this word is not, so what we are doing is we're iterating over the words inside text list, and we are trying to check if the word is not in stop words. Then we'll go ahead and grab that word, and we'll store it in this text underscore no stop list, and we'll be returning this list. So let's say return text underscore no stop, and run this, and let's go ahead and apply this on our data set. So we're going to create a new column from this text underscore tokenized column, and remove the stopwords. So I'm going to apply lambda function to remove call this remove stopwords method, and remove the stopwords from our tokenized list of words. So I'm going to say data set, and we're going to create a new column. So I'm going to give the name as text underscore no stop, and we'll be working with this column. So that's text underscore tokenized. So let's say data set text underscore tokenized tokenized, and I'll choose the apply method. So dot apply, and I'll be using the lambda function. So lambda x, and I'll be calling the remove stopwords function and passing in x. Let's go ahead and run this, and let's print the data set, the first 5 rows inside a data set, and let's run this. So we have our new column called text underscore no stop, and if you take a look, we can see until is removed, and there are a few other things that are removed. So this one w in is removed, and say is already there, then is removed. So we can see we have a few words removed from our data set, and Python has now to deal with lesser number of words. and the words that do not contribute much to the meaning of the sentence have been removed. So now we'll be moving to stemming and lemmatizing. So if we take a look at pre-processing our text data, we have removed punctuation, we have removed tokens, we have tokenized our data into a list of words, we have removed stop words, and now be looking at stemming and lemmatizing. So let's first go ahead with stemming. And if we go with a formal definition of stemming, stemming is a process of reducing inflected or sometimes derived words to their word stem or root, that is base word. So that means crudely chopping off the end of word to leave only the base word. So if we are dealing with words like running, run and running, so these are similar in meaning, and if we just chop off the run ing from running, it remains same, or it means same as running. And Python has to deal with one word instead of dealing with two words, and that means lesser amount of storage in the memory and lesser memory consumption. So that is basically crudely chopping off the end of the word to leave only the base word, or taking words with various suffixes and condensing them under the same word root or root word. Group or stemming can also mean group words with similar meanings under a root word. So example, let's take a look at some of the examples of stemming. So if we are looking at these two words, stemming and stemmed, we can chop them off and we can trim them down to stem. So we are just removing this part of stemming, and we are just removing this part of stemmed, and we are trimming them down to stem. And if you look at electricity and electrical, it is stemmed down to elector, which is just crudely chopping off the end of the two words and trying to group them into one word with similar meaning. And if we are looking at words like connection, connected, and connective, we can chop them and we can trim them down to connect, which have the same meaning. And if you are taking a look at words like berries and berry, we can trim them down to berri. So while stemming might be really useful, sometimes it is not accurate, sometimes it is not correct. So if you take a look at words like meanness and meaning, which are very different in meaning, both of these words are trimmed down to mean. So that really is not perfect, and that is not accurate. And now why should we stem? Similar to stop words, we stem because we want to save memory, or we do not want Python to look at a huge number of words. So if we had to store all the words, all the variations of the root word or the base word into the memory, that would be a large amount of data that we need to store in our memory, and that would be very difficult to store. So without processes such as stemming, we would need to keep all words in the memory, which would be really difficult. In fact, in the corpus we have just 2000 total words. So in the stemming corpus we just have 2000 total words, and all the different variations of words are reduced or trimmed down to a base word and stored as a group, instead of having to store all the words, all the separate words separately, right? And stemming reduces the corpus of words the model is exposed to, and it explicitly correlates words with similar meanings. And now let's take a look at some of the stemmers in NLTK. So we have the Porter stemmer, we have the Snowball stemmer, we have the Lancaster stemmer, we have the regex space stemmer. And in this course we're going to use the Porter stemmer, which is one of the most popular stemmers with NLTK. And let's take a look at how stemmer actually works. So I'm going to say import NLTK, and I'm going to say PS. So that's Porter stemmer equals to NLTK dot Porter stemmer. Let's run this and let's try to stem a few words. So I'm going to say print ps.stem, and I'm gonna pass in running and print ps.stem run. So let's run this. So we can see both the words running and run are chopped down to run, or they're trimmed down to run, right? Now let's put another word and say, let's copy this, paste it, and let's say runner. So we can see the first two are kind of similar in meaning, and they indicate an action, and the last word runner actually indicates a person. So let's try to figure out if stem or the NLTK Porter stemmer can actually differentiate between these two. So let's go ahead and run this, and it actually does differentiate between running, run, and runner. So the first two are grouped as run, and the last one still remains runner, right? Now let's try out some more examples and see how they work. So I'm gonna say print, so let's keep this same, and I'll say growth, and growing, and let's run this. So we can see these two words, grow and growing, are grouped into grow, and growth still remains the same, right? So let's go ahead and build a method that stems a list of tokens, and then we'll be applying that to our data set. So I would say def stem underscore tokens, and this would take a list of tokens. So I'd say token underscore list, and we'd be storing the stemmed tokens into stemmed underscore list. So we'll be going through each word in the token list. So I would say for word in token list, so that's going to go through all the words in the token list, and I'm going to grab that word and I'm going to apply the stemming to this word. So we're going to say ps.stem, and we're going to store the word back into the list, the stemmed list, and we're going to return the stemmed list. And let's run this, and let's apply this to our data set. So we right now have this text no stop column which we're working with, and I'll just go ahead and build another column which would be having the stemmed words inside that column, and we'll be stemming these words inside text underscore no stop. So I would just say data set, and we need to give a name to the new column. So I'd call that text underscore stemmed equals. So we'll be working with this column here, text underscore no stop. So I'm gonna say text underscore no stop, and we'll be applying the lambda function. So I say apply lambda x lambda x to, and I would call this stem underscore tokens method, and I'll pass X. Alright, let's run this and let's try to print the first 5 rows inside our dataset. Okay, so we have the stem text, right? And if we take a look, joking has been converted to joke, and available has been converted to avail, and goes has been converted to GOE. Lives have been converted to live. So we can see our words have been stemmed. So that is about stemming, and in the next lesson we are going to take a look at lemmatizing and try to understand how lemmatizing works. So that is all for this lesson, and stay tuned for the next one. Bye.